Welcome, data people. We are Zuma. My name is Matt, and this is the Data for Good podcast. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company focusing on data positions across Berlin. The Data for Good podcast is for the world of data science, analytics, and engineering, giving you a platform to hear the thoughts and opinions of data leaders from Berlin and beyond. Today, we are joined by Paul Weber, Senior Product Manager at wattX. Paul, welcome. How are you?
Great. Thanks. Hi, Matt. Thanks for having me on your podcast. Really happy to talk to you.
It's an absolute pleasure to have you on. So first off, for those who don't know who you are and what you do, can you give us a short introduction?
Yeah. My name is Paul. I'm a Senior Product Manager at wattX, a venture builder in Berlin, working on mostly climate tech and data and AI projects for corporate venture building and venture building out of our own initiatives. My job here is to lead the projects when they go from the early venture development in the product building phase and mostly software development projects. My background is actually in physics, where I started to move into optics and imaging, which then turned into computer vision and machine learning, and has been for more than the last 5 years, mainly project and product management with applied research and productization of AI to problems in computer vision, but also in audio, digital signal processing, and more recently, media processing, generative AI. And that's kind of my profile. A bit between the tech side, but today mostly in management. Yep.
Awesome. And then today we're going to tap into that wealth of knowledge and wisdom to share with the listeners. So today we're going to talk about AI, ML, and what that means in an industrial environment. So a good starting point. Tell us what we mean when we talk about an industrial environment.
Yeah, so this is actually the space where I had the most experience as an engineer, where you're working with usually business customers and mostly producing goods, like in manufacturing, but also chemical engineering and pharma, like typical industrial environments where you have processes which have in many cases today highly automated already. And this is the kind of environments where you have to think about large machinery or devices, often some involvement from the human side, but in many cases automated systems to produce goods, all kinds. And this is where I think also there have been a lot of early successes for machine learning and data science, with of course computer vision as one of the most mature fields, also the field where I basically entered this domain, where there is just if you do in an industrial environment, in many cases you want to produce repeatedly the same quality of goods, and that's of course a problem that is very well suited to all the solutions are well suited to this problem on the AI side, to check for patterns, to get repeatable results, which at industrial scale is kind of in most cases the requirement to produce the same product over and over again. And I think that is where AI in industrial spaces got basically a lot of early success, and has been, I think, moving from expert systems to more statistical modeling, to deep learning model, to computer vision systems, to end-to-end optimization of large machinery, is basically today a part of many processes, and still innovation in otherwise quite mature field.
So it sounds like when we talk about industrial environment, we're talking about the real world as opposed to digital e-commerce.
Yeah, exactly. I think and if we're looking at this, it's usually primary manufacturing of materials, or secondary, where you're manufacturing goods based on materials. In both cases, actually, you need a lot of quality control or stabilize the system, and very much a real world, real impacts hardware business, not hardware in the I know electronics hardware sense, but yeah, like real world applications.
So when you've mentioned a couple, when we talk about AI, ML in digital and e-commerce, it's recommendations, it's pricing. How does it differ in the real world, in industrial? You mentioned a couple. Can you tell us a bit more?
Yeah, I think like one of the reasons that computer vision is so dominant in industrial applications or has been so successful is that you're dealing with something that is tangible, but it's not necessarily like measurable with data in the same sense as you have it in I don't know, e-commerce churn prediction optimizer, where everything is already basically data in the cloud. And in most cases, actually in manufacturing, you have a process where you want to do some kind of non-invasive measurement of the process. So you want to basically observe the process without interfering with it. And that just is something where imaging or visual inspection actually has been like the main way to do it with like human quality control. Or you would take a sample from the process, right? So this is basically the ways to get data out of the process. Either you observe it or you take a sample of the production line and you test it. And traditionally, if you do this with like a human quality control system, you can only do this like every, I don't know, like a few pieces or like a couple of times a day. It's very, also takes a lot of concentration or like an expert who actually knows how exactly the product needs to look at this stage in the process. And what we see with basically non-invasive measurement techniques, imaging being, I think, the most relevant here, is to observe like different steps of the process without interfering with the product, and doing this for every single product on the line. So you basically do a 100% quality inspection, which is like another thing in industrial. There is, if you have a complex system, you need very strict quality control for every part of the system, because otherwise you just get a high chance that one part is like, if you automate everything, most of it, like and one piece is not of the right quality, basically the entire product in the end is going to waste. And one of the big goals of industrial automation is to reduce waste and also reduce kind of like steps where you need to rework and change something, which requires like then a lot of manual labor, requires also new energy, new material, and produces a lot of waste. So a lot of the kind of lean production techniques that are older than the AI automation already are aiming to create like a wasteless process, or like where like a single piece that is not of the right quality is removed immediately, rather than basically put it downstream in the production process.
Yeah.
This is just where if you have like an AI system that can basically confirm that like a measurement system that can confirm every single basically step of the process, ideally you avoid waste, meaning you have a higher throughput. You don't have to stop the machine because something is broken. This is kind of like this entire lean optimization, measurement and automation, and then AI quality control all works together to create a high efficiency industrial manufacturing, leading to higher quality, leading to in some cases even like products that otherwise wouldn't be possible. If we're thinking about like some semiconductor tech or like some displays, for example, where you don't want to have like dead pixels on a screen, and you want to just, for this you really need to image this and check whether everything is working. Just one example. And you don't want to bring any panels into the next step when you know like you can't fix them afterwards, right? So this is, I think, what's different here is that you need to do like inspection of like physical real world parts, and imaging is one of the ways to do it. And there for image analysis, deep learning is the way to do it, or like is one of the ways where there were breakthroughs to get from very like often like not well performing measurement and automation systems with like some expert systems or whatever algorithms were used
Yeah.
to move to trained on data visual inspection systems with deep learning models. And I mean, that's been not solved, but has been working really well for longer than many other deep learning applications where we now see breakthroughs in text generation, but that came much later. So like on the side of unstructured data, which we have in this inspection, basically images have been the kind of like the format of data or the modality of data, where deep learning has been the only good way to do it or like the first good way to do it.
Yeah. But for those who are new to computer vision, and especially within industry, what's a really simple example or a use case of how this is used?
Yeah, so one example, something I worked on like I know over 10 years ago, like visual inspection of surfaces in production of like a semiconductor technology, where like different layers of a semiconductor stack are needed to have a certain functionality, and you just want to check that there are no holes in that structure, that all the basically the different layers in the stack have the right thickness, which you can get through like kind of a visual inspection with how they're reflecting based on the thickness, and all of this basically can then be combined in like different steps of visual inspection to make sure that every piece in the production line basically meets a certain standard by also just then removing the like defect pieces from this production line. And then like in a different process, actually also something I've worked on is like to, for example, for the quality of like semiconductor material, is just like very early in the process to do quality control on the basically source material, which is like high grade silicon, like pure, to also do like control on the type and the size of particles that are going in very early in the production process there.
Wow, so it's really honing on efficiency. Go on, sorry.
Exactly, and in the end, like you need like a lot of quality control at every single step of the process to do something like semiconductor manufacturing, which is very much like high-tech science, but also like depends on many steps with a like very pure production and like zero defects. And like a single defect in the production process basically leads to like a waste where the entire product is not usable. And it's one of the examples where this is very important. Another example would be automotive manufacturing, where you just have so many parts that are needed to build a car. And if one of them is broken, basically the car will be returned to the dealership. And that's like one reason why in car manufacturing, also like single part quality control has actually been like longer than it's been like AI enabled, but has been like a kind of a requirement for a long time.
So efficiency is a big one. When we talk about the AI and data in tech and digital, it's often for profit, sometimes customer experience and whatnot, but in industry and real world, it's not only profit, it's waste and lack of and sustainability. So yeah, something you're passionate about. So yeah, tell us a bit more about reducing waste and using data in industry.
I think like coming back to like these large scale industrial processes, I think like two things most of these processes have in common, like is that they're very energy intensive. So you need a lot of energy to do this process, and that once you have waste, like it's near impossible to recycle the product. So everything basically that goes like that fails quality control in the end is usually like a composite, like a very complex thing that you cannot easily recycle, where you may have like rare materials or basically that are then bonded into something that you have to throw away and probably have to put in a landfill or something. I don't know. You don't want to know. Like you don't want to know in many cases what happens to waste that goes off the factory line. And I've actually worked on, because I've worked in this kind of industrial like measurement and automation inspection, worked on a lot of projects where the amount of reduced waste was like very significant, like a large part of materials, also allowing these production lines to run more efficiently, to optimize things, to also like require less maintenance, but also like just the more like in this case, like the business is very interested in having like a smooth process and little waste, but it's also a positive impact for the environment, because you need less energy, you need and you have like less waste, where in the end, like many products are also built on like fossil. If you think like anything that's made of like composite plastics or something, or you have something with like metal where you have aluminum, which is very energy intensive to produce, right? So in the end, like a more efficient process reduces the carbon footprint of the effective product, because what I think, and usually industrial manufacturers don't do this, they need to include the carbon footprint of all the waste in the products, like proportionally to what's needed there. Yeah, and that's one way to it, but they're also like, not like, I haven't worked on it, but of course there are a lot of applications for data science to work on more climate tech directly, where like data science or like modeling is used to find new materials, to find more efficient processes, and overall optimize like often like legacy technology, and like that is of course like a huge industry, like climate tech, that has like in the like modeling as part of basically understanding the problem, but also to find solutions, find new materials, find new processes, or use automation and also control systems to make new processes stable enough that they can compete with legacy processes, which are fossil based and maybe like inefficient or like with a high energy consumption.
Yeah. How much have you seen this evolve over the 5-10 years, that efficiencies and sustainability has become much more, and rightly so, a priority?
Yeah, I think what's actually changed is that like a long time, like these industrial applications were really about efficiency and quality control and better products, lower costs, and that is what was driving also adoption of this. But today we have climate tech as an entire basically industry, or like it's like or a different perspective on industries, like to think about like, okay, this is actually like one of the worst polluting industries, or like one of the most inefficient, and then you have companies using data and very much using like the same solutions in some cases, or like similar solutions, and apply them to say like, oh, let's not just make this existing process more efficient, but let's actually rethink this, like with the modern technology that we have, with the understanding that we can get, with data that we collect, how can we like rethink this and make it different, and also extends what like climate tech is not just like on industrial applications, but in many cases also to innovate in industries, with often like a very digital approach to also optimize, for example, like optimizing the size of like that's something like at wattX I'm working, like it's kind of like the type of topics we do, like optimize like what kind of like solutions, what systems we are recommending to like for certain like installation, like a problem there, and actually like find the right sizes and like optimize this to like match kind of like the small enough or well sized solution, which if you weren't able to model this properly, or if you would just to guess it, you oversize everything and you build like inefficient systems, right? So this is like this entire climate tech end to end, and thinking about like, okay, this is a very complex problem. There's a very that doesn't just include like producing like materials or machinery, but also like the entire life cycle. Like how can you like maintain them? How can you optimize this to, if you look at the entire system, have like the minimal carbon footprint, but also like lower cost, which in many cases actually is quite related.
You'll have a bit of an overarching view of the nature of the business at wattX. What kind of innovations are you seeing in this area that a lot of people are thinking, yeah, we need to get on that as well?
Yeah, I think this is also something that has changed. So wattX comes out of kind of climate tech company, like as a venture studio for it. So there's always been a strong fit also to like manufacturing of climate solutions. And in the past, there on the especially on the AI side, there have been a couple of successful ventures that were founded and spun out that were working on computer vision for like better IoT. Edge devices for computer vision, for better labeling tools for images, but also for like non-industrial applications like anonymization of data. And I think this has been kind of like one of the focus fields. But today we're looking at more specific like also like societal problems. Like if we're looking at carbon technology, so we're looking also a lot into understanding how solutions that are part of like of course like very complex topic of like decarbonizing, doing reduction of carbon output, doing carbon dioxide output, doing avoidance, or doing actually also carbon recovery, like to kind of catch it from the air. And I think in this space, that is also very much an industrial problem, like something that will need like hardware. Actually, like it's not something you can solve with a model, but data is needed for like understanding and also designing solutions there, and also to overall basically innovate on these industries. So that's one of the big parts that we're investing in. And the other side is actually more also the human side of this. So we have this climate tech industry, and we're also looking at like manufacturing and industrial applications, and think about like how can AI on, for example, also on the language model side, improve basically the efficiency, or like also like the capabilities of these companies to innovate, to change, and also to do things at scale. Because like one of the big challenges we see right now is that there's like good climate solutions, but we don't have, for example, enough skilled workers to do all the just operational work of like installing these systems. And so one of the projects we're working on is also like more in the like right now, like in like more like even like an educational topic. It's like how can we connect in the end like data that's more like on like technical documentation, but also like educational material with people who are actually working on these systems in the field. How can we help with overcoming skill barriers and also language barriers, if we're also looking at like how is specifically Germany solving a labor shortage in this space. And there is like kind of like there are a lot of like small aspects to this, and some of them can be that's what wattX does, like can be productized and actually become solutions for companies that we're working for. And some of these actually might have the potential to become kind of venture scale startups, and those are basically spun out. I think this not everything we do needs to have a venture capital case. Not everything. So some of this can become like actually a product in a corporate, can become a corporate venture, or can be spun out. And so there's like lots of different problems. And I think what's now, I think part of the hypothesis is that AI will play a big part in getting much faster than we actually like on track right now, to innovate and also to change things in companies, but also on a where these companies impact, or where they're the dependency for the society to change and find new solutions, and also do this like cost efficiently, of course, which is always part of that. The question like how far can we get?
Yeah, are we missing domain experts or technical data experts?
I think this is like definitely in manufacturing companies and in industrial context. I think a lot of companies are missing also like the software engineering and data expertise for people to help them through this transition, to adopt also the technology that is for some available, but it's like if you want to apply to your own company, like there's always a specific use case. But we also see like, and that's like one of the problems we're tackling. There's just also a lack of not just domain expertise, but also just the like blue collar workforce, for example, to implement things. Because like a lot of things, like when we think about blue collar jobs, it's like very, I don't know, manual labor, but it's, to be honest, if we're looking at climate tech, it's often like it's already high tech. It's already very complex systems. You need like to understand how to do this, how to install, how to debug something when you're installing, how to maintain, how to service. And I think that's one of the also like very interesting topics for us, where like right now, like the climate tech space is blocked by, or like could be unblocked if we have better access to, in the end, knowledge management solutions and productivity tools that are not just, not just generate that blog post for me, which is where generative AI, I think, made the first breakthroughs with copywriting tools, and is now coming to other domains, coming to other modalities. But for us, also like reaching people in blue collar jobs, or like in very specific domains. And I think that's just super interesting and very also like it's very challenging, because you're dealing with different modalities of data. You're dealing with images, with technical drawings, and you're dealing with also maybe outdated information, right? Like it's like and then you need to bring this at the right time to the right person who might not even know how to like ask that specific question. And I think that's also the beauty of like these, basically the now like emerging generative AI solutions, is with a combination of searching and generating, is to connect things that seem like, oh, that's even of a different data format, and that's like that's actually way too technical, way too complex in a different language, and I can still bring this basically to the place where it needs to be, to unblock someone doing a physical real world job, right? I think that's is ambitious, but also I think where generative AI is going, even to these industrial cases.
Do you think the risk is maybe too high with copywriting? There's no risk. Someone writing a tweet, you're not gonna break anything.
I think that one of the nice things about like industrial applications, they were usually working with proprietary in-house data for the company that's using it. For me, like in media, or like in more like public facing things, so if you're doing a copywriting tool, or like something that is like for publishing, I think copywriting is a bigger problem. More the concern we see like in industrial cases is there's a lot of concerns about like leaking data. There's also, if it's like for like employee tools, like data privacy, German companies often are rather conservative on adopting IT solutions, even cloud solutions. And that's a bit like the cloud is a big enabler for like generative AI, or like these solutions connecting data. So for us, it's rather like, how are we leveraging that data that's existing internally, maybe in legacy systems, maybe in proprietary formats? How do we get it out? How can we make this kind of extract, transform, and load it into a state that is in the end then basically accessible for like indexing, and also like AI ready in a way.
We could probably go on for many hours talking about this, but I am conscious of time, so we're going to finish up with one question. So industrial environment, AI, what are you most excited about? What do you reckon you can do?
I think for me, like there's like the kind of the solutions are existing right now, and I think one of the most interesting things is to make this work for like a positive impact, for improving climate tech solutions, for bringing them to market, but also to making AI work for people, like as an enabler, and as something that is kind of like making things more accessible for humans to do, and increasing their capabilities, their productivity, also like in a kind of upskilling way. and not as something to replace them, which of course, like there are some concerns about this, but I think there's a lot of ways this can go wrong, but there's also so much positive impact that can be created. And I'm just like, of course, hoping that what we do will have a strong positive impact. Yeah, and this is, I think, yeah, it's an exciting time with all the new technology available on the solution side. And there are these huge problems, like these challenges for society and climate tech as a whole, but also with other topics. And I think finding that match, I think that's for me also as a product manager, like the fit between these problems and like solutions is just I think the best part of the job. Right?
I hear. I mean, data is a super exciting area right now, but combining that with the real world and sustainability and climate tech, it just adds that something special to it as well. Completely agree. That unfortunately means the end of the episode. That's all we have time for today. But thank you very much for your time and your rich insights, Paul.
Thank you for having me.
Yeah, it's been an absolute pleasure. To listeners, of course, don't forget to like and share so we can reach as many people as possible. But it is bye from us. Thanks once again, Paul.
Right. Bye.
Ciao for now.